We're going to look at doing some arithmetic with functions. And the arithmetic with functions is similar to doing arithmetic with just plain old numbers, but we need to add whole functions or subtract whole functions instead of just the plain old numbers. So first thing, remember about function notation that you have this notation which gives the name of the function. So the name of the function is f, and the variable that we're going to be working with is named x. So x is our input, and we're just giving the name. So this is not a multiplication. It's not indicating to multiply f by x. It's indicating that the name of our function is f. I mean, we could call it Fred if we wanted to. And it says that the variable that we're going to be working with, the one we're sending into the function, is going to be called x. So now when we look at some arithmetic, we have this notation here. So f plus g is the new name of our function, and it indicates our new function after we've added our two original functions together. And the input or variable that we're going to be working with is called x. So to add two functions together, I'm simply going to take the two original functions. So I'm going to take my x, my f of x, and I'm going to add it to g of x. And then I'm going to simplify if I can, and yes I can add together the x's to get 5x, and I can add together my numbers to get a minus 2. So f plus g of x is equal to 5x minus 2. Now let's look at this next situation. We have a new function called f plus g, and it's going to be the result of adding our two original functions together. But what we're going to be using as an input is the number 5. So now whenever we see an x, we're going to substitute a 5 instead. So in our original function f, we have 2x minus 4, but we're going to substitute 5 because now 5 is our input instead of x. And for g of x, wherever we see an x, we're going to substitute that 5 because likewise 5 is our new input rather than x. And when we do this arithmetic, let's see, we're going to get 10 minus 4 is going to be 6, plus 15 is going to be 21, plus 2 is going to be 23. And I want you to realize that this would have been the same and actually much easier if we had gone ahead and plugged our 5 into our previous result. So if we had just gone in and plugged in our 5 here for our x, we would have gotten the same thing because this 5x minus 2 represents the addition of those two functions, our two original functions. Well, let's go on and take a look at subtraction, and I'm imagining that you've already figured this out. When we subtract these two functions, we're going to take our original function f, so 2x minus 4, and as you can see, our input is going to be x, so our x just stays as x. Then we're going to subtract our function g, which is 3x plus 2. Now if we go through and simplify that, we're going to have to distribute that negative sign, so we get a minus 3x minus 2. And simplifying that even further, we see we have a 2x minus a 3x, so that's a minus x, or a negative x, and we have a minus 4 and a minus 2, giving us a minus 6. So when we subtract the two functions, we get a negative x minus 6.